Yes, so that is our graph. We have seen the shape of our graph. It goes that way. That is the shape of our graph. Now, this is the shape of our graph. Let us use this graph now to answer questions. The first question from that graph, we are told from the graph, determine the concentration. Determine 1. Concentration of bromine at 100 seconds. Concentration of bromine at 100 seconds. So you go back to your graph. After going back to the graph, you check where the concentration is 100 seconds. No, where we have 100 seconds. Time is on the x-axis. Therefore, what do? We come to where we have the time. Then you look for 100. You look for 100 seconds. And 100 seconds is somewhere here. So then you read it backward. So if you read 100 seconds, you'll find that the 100 seconds is here. It is here. The dotted blue line. So you draw a straight line to cut the curve. Where it meets the curve, you draw a straight dotted line to the concentration axis, y-axis. Then you read. So in that case, if you read that, you find 65.55. 65.5 times 10 raised to negative 4. So what you get is 65. What you get is 65.5 times 10 raised to negative 4 molar. Or you can write it in the normal form. You remove the standard form. You will have 0.0065 molar. So that one will be the concentration at 100 seconds from the graph. Then Roman 2, the time when the concentration of bromine was 0.0025 moles per decimeters cubic. So the time when the concentration was 0.00. Now you go back to the graph and you check when the concentration is 0.0025. 0.0025. You come to 25. Because if you are given 0.0025 molar, it will be 1, 2, 3, 4. So it will be 25 times 10 to negative 4 molar. This one is what you will read from the graph, because the graph is 10 to the power negative 4. So when you come back to the graph, you check 25 times 10 to negative 4. So you come and you check where there is 25. 25 is between 20 and 30. So we have 25 here. Then you put your ruler, you draw a dotted line, then you drop it down there, and then you read. So if you read that, you'll get 396. You get 396. So when the concentration is 25 times 10 to negative 4, which is 0.0025, the time taken will be 396 from our graph. Then we move to the next question, so you can see 396 seconds at 0.0025. So that is what we have as that. Then we are told determine the rate of reaction between 90th and 20th seconds. Here we are going to get the average rate between 2 points. So the question is testing on the average rate between 2 points. How do we get rate? The rate is the gradient of that curve. And how do we calculate the gradient? Change in concentration over change in time. It can be change in y over change in x. So we come to the graph and we look for 20th second and 90th second. 20th second and 90th second. So on our graph, we check where is 20 seconds. 20th second is here. Then we join it, we draw using a ruler, we draw a dotted line to cut the curve. Then we drop it. So where the line on 20 seconds meet the curve, we get the coordinates. And remember the coordinate is x, y. So 20 seconds, the concentration is 93 times 10 raised to power negative 4. So we have that. These are the coordinates. Then we look for 90 minutes. 90 minutes is here. So again we drop a straight line to touch the curve. Then we drop it to the concentration axis. We read the time is x-axis, xy. X is 90 seconds. And y is 72.5 concentration times 10 raised to power negative 4. So we have the coordinates. We have x, y, x, y. Then now when you want to calculate, the average rate between these 2 points, you simply calculate the gradient. But now here you don't draw a tangent. You only draw a tangent when you are calculating a gradient rate at one particular point. But this is the rate between 2 points. So what do? You check change in y over change in x. You can take 90 minus 20, because change, or you can take change in y over change in x. So y is 72.5. You check change in y is 72.5 times 10 to negative 4 minus 93 times 10 to negative 4. Divide by change in x. Change in x is 90 minus 20. That is what we have done here. Change in y over change in x. Then you get your rate. And the rate must be per second. The unit for rate is per second. Must be given. Now explain how the concentration of bromine affects the rate of reaction. We have explained that the higher the concentration of bromine, the higher the rate of reaction due to increase in the number of collisions per second. And then on the same axis, sketch the curve that would be obtained if the reaction was carried out at 25 degrees Celsius, and label it what? M. This one is your assignment. Draw the first graph. Then, after drawing the first graph, the one that we have discussed, then also sketch the second graph at 25. This one, label this as 40 degrees Celsius. Then sketch the other one, whether it will come this way, whether it will come this way. Then you label it what? 25 degrees Celsius, whatever. But sketch it. I want to see how you do that graph. That one brings us to the end of our class today. Thank you for watching. Let us meet in the Google Classroom.